Welcome back, Dr. Chris Smith. Good to have you.
Good to talk to you, Clarence. Good morning.
You'll remember we've had quite a couple of questions, so we want to intersperse last week's questions with some of the questions that have come through this week. Are you okay with that?
Well, just to be clear, these are, of
Well, just
course,
to
the
be
ones
clear,
we
these
didn't
are
get to last week, aren't they? So these are
yes.
very valuable questions because every question's an important one. But if people do get calling now, as opposed to wait for just a minute before we finish, there's a great chance we'll get this week's questions in as well.
Yeah, that unfortunately is what happens every week. We get all the questions after you say goodbye. So we're trying to prompt people just a little earlier to get their questions in. But one of the questions in from a really exasperated person by the sounds of things is the question about cluster headaches. Can you talk to this person about cluster headaches and if there's a cure?
This is a really, really uncomfortable phenomenon. It's more common in men than women, young men especially. The term cluster headaches, they do exactly that. You get an abrupt onset of very severe, very disabling headaches that come on off the back of being perfectly fit and healthy and for no reason. And there's a range of people who tend to get them. They can run in families, and they also can disappear as fast as they start to come. So people usually manage them with painkillers and that kind of thing, and then hope that after a period of time of having them, they will then recover. But there's no guarantees. You can never say never in medicine, but usually it does stop. They come in clusters. You have a run of them, and then they go. The mechanisms I think are quite poorly understood. The usual things we point the finger at when this sort of phenomenon occurs is something in your family history. There are some people who have this as a sort of phenomenon, and so therefore if a relative has it, you may be more likely to have it. Some drugs are thought to provoke this. There are also exposure to some environments or stimuli, or stress is also thought to be linked to this. So there's a range of different things that can cause it, but luckily it does tend to go away spontaneously. But managing it with painkillers when it does happen is the order of the day.
Then we have Rita. Rita's on the line. Rita, go ahead with your question.
Hello, Dr. Chris. I'd like to know why some women, when they're pregnant, first couple of months are violently ill with morning sickness, and others sail through without any problems. So I'd like to know. Thank you so much.
We don't know why we get morning sickness, but what we do know is that as soon as a person isn't pregnant, it stops, and a person doesn't have morning sickness when they're not pregnant. So there has to be something about the physiological demand and the hormonal demand being placed on a pregnant woman that makes the body react in this way. Now, speculating, one possibility about feeling sick when you're pregnant is that you tend to feel most ill and have the worst morning sickness symptoms when you're at the stage of pregnancy when the baby is developing all the major organ systems. And this is when the baby is most vulnerable to damage caused by external influences like drugs or toxins and that kind of thing. So some people have speculated that one of the reasons we go around throwing up is because you are minimizing the chance of exposing the baby to things that could harm it when it's at its most vulnerable, because all those organ systems, when they're first developing, are very delicate, and if you disrupt the foundations of a building, you destabilize the building indefinitely. So make sure you've got good foundations, you have a good, strong, firm building. It's the same with organ systems in the baby. That's one speculation. Another possibility is just that as the mother is getting used to these hormone fluxes, as the baby begins to develop and hormone levels do swing wildly, this is also a process of adaptation, and that this in some way causes the body to respond in this unpleasant way for some. Some also say, well, if you are pregnant with a boy, you get different symptoms of morning sickness compared to girls. And some people say that if you're pregnant with a female baby, the morning sickness may be worse than if it's a boy. Not sure whether there's really good evidence to support that. So really it comes down to some people get it badly, some people seem to sail through, some people don't even get it in the same with subsequent pregnancies. They have a bad experience the first time, they don't necessarily have a bad experience the next time. Others, on the other hand, do. So it's very variable, but we do know it's very, very common. We also know it tends to be worse in the initial phases of pregnancy and then gets better after you're into the so-called second trimester. So if you are suffering badly, then do seek help, because the thing is it can be serious, and some people can end up admitted to hospital because of dehydration and that kind of thing. So don't suffer in silence. silence. Do ask for help. Some people can help you. Some people have suggested that ginger can be very, very useful. I know many women who've said to me that they've put ginger in water, and sips of ginger water have helped them to keep a lid on things. So maybe that's something to try as an initial simple remedy if you're not coping to start with. But don't suffer in silence. Do ask for help, because you may need more help, and also you may be able to get some practical advice on how to manage this better for you.
Thank you, Rita, for your call. A voice note from last week on the experience of smell. Let's take a listen.
Good morning, all. A question for Dr. Smith. The experience of a smell that is connected with phantosmia, what generates the smell, and is it the same for everybody, or does every person have a unique experience?
The smell system is a really special one. It's, in evolutionary terms, a very old system, in the sense that if you look back in very simple animals, they have a smell system that works very similar to our own, and it's unusual in that the system that runs the detection of smells plugs straight into the brain, and it plugs straight into the underside of the human brain, right next door to where we have our emotion center and our memory system, the hippocampus. And this has led scientists to speculate that the reason smells are so powerful in terms of eliciting memories, taking us back decades sometimes when you experience a smell, or being involved in olfactory hallucination when you smell a smell that isn't really there, and that's what is being referred to here. This could be because it has this direct connection to these extremely primitive but extremely powerful parts of the brain. And the answer is that no, different smells will elicit different experiences in different people, and smell is very similar to sight in the sense that what I call blue and red and green, I call those colours, those experiences of those colours, what I call them because I've been taught that's red, that's blue, that's green. And in the same way that when you smell a smell, that's a neurological experience, and people tell you, that's the smell of roses, or that's the smell of mint. And the reason you call it that is because that's what someone told you that experience is called. So it's impossible to say that my experience is the same as your experience, because it's just a neurological experience. It's a bunch of nerve cells firing off an experience into your brain and recruiting and eliciting a series of memories and emotions. So those are not going to be necessarily the same for everybody, and in some people a smell will summon up a very nice memory or a nice experience. In others it can summon up a very unpleasant one.
Let's go to a voice note that came through today. It's about sustainable fuels.
Good morning, Clarence and Dr. Smith. Quick question. I like my cars. I'm a petrolhead. What is the way forward with regards to sustainable fuels? How does it work? Like, how do you take a conventional vehicle or combustion engine, and how do you actually get it to work with a different fuel? I'm just curious. Thanks. Jason here from Brackenfell.
Hi, Jason. Well, it ranges from the simple in the sense that in Brazil, warm place, lots of sugarcane, same for the Eastern Cape and up near Durban, of course. And you can produce enormous amounts of sugar. And if you've got lots of sugar, you can produce alcohol. And alcohol behaves a bit like petrol. So you can supplement your fuel with alcohol or almost exclusively replace your fuel with alcohol. The energy density in alcohol isn't quite the same as the energy density in petrol. But at the same time, if you've got a plant which is pulling carbon out of the atmosphere to build molecules of sugar from that carbon, then it's a carbon neutral process. You haven't had to remove any oil from the ground in order to produce that fuel in order to power your car. So when your car burns the fuel, it just puts carbon back into the atmosphere that was there already. So that's at one end of the spectrum. The next part along the way is to say, well, do we have to use that sort of fuel? Well, maybe not. Maybe we switch to hydrogen as a fuel. And there are now a number of initiatives in play where people are looking at either burning hydrogen in engines or, more likely, burning hydrogen in a system called a fuel cell. And fuel cells are giant catalysts where you feed in hydrogen. The hydrogen is reacted with oxygen, but you do it in such a way that you tap off the electrons which would be taking part in that chemical reaction, put them round an electric circuit first and make them do electrical work for you, and then you produce the product, which is water, because when you burn hydrogen in oxygen, you get water, H2O, which you can then throw away, and it's non-polluting, but you've extracted some electrical work in the meantime. And there are a number of initiatives now that are doing this, and they range from small vehicles through to big trains that are doing this. And the benefit is you don't have, again, to burn carbon or remove carbon from the ground in order to do this. But the hydrogen you use, if that is itself polluting, as in it's come from a polluting source, then really you're not much better off than if you just burned something that was a fossil fuel. Let me explain. There are a number of ways to get hydrogen. One is you can make what we call green hydrogen, which is you take a solar panel, you capture some sunlight, you use the energy to produce electricity, you use the electricity to split water into hydrogen and oxygen, and you use the hydrogen. Green. There's no carbon footprint to that. But then there's so-called blue hydrogen, where you take a molecule like methane, natural gas, and you blast it to pieces, splitting off the carbon and the hydrogen, and you get carbon, which is in the form of carbon dioxide, and hydrogen. And if you sequester that, that's fine. Keep the carbon locked away, that's fine. But if you release the carbon dioxide into the atmosphere, well, that's not really much better off than if you just burn the methane to start with, and that's what we call grey or black hydrogen. So there's a range of different ways to do that, but again, it's electric. And then you've got the full end of the spectrum where you build an electric car where you have batteries, and those batteries run motors, and you charge the batteries with electricity, which you've hopefully sourced from a sustainable source like solar panels, wind power, water power, and so on. So the answer is that the internal combustion engine might have a role to play in some of this, but most people think that we're moving towards electric motors, which can be much more powerful, much more efficient, but you've got to make sure you power them with a sustainably sourced supply of electricity.
Another message, and of course, it is our time with the Naked Scientist, Dr. Chris Smith, Chair of Science at the University of Cambridge, on the line from the UK. A question in from last week. Hello, Dr. Chris. Why do some parts of California have a sunny Christmas and New York has a snowy Christmas, and they are both above the equator? Jill asking that question.
Well, Jill, the answer is that obviously they're a very long way apart. It's thousands of kilometres between the two, and one is in the far north, one is in the far south. New York is a long way north and California a long way south. The answer will really come down to the climate is driven by weather pattern. The climate produces weather patterns, which will be because of the geography, the transfer of energy through water. They're both coastal, but one's on the South Pacific coast, one is on the North Atlantic coast of America, they're in the coast of New York. And therefore, the amount of energy that comes in from water and from wind, prevailing weather systems, will be quite different between the two and different at different times of the year. New York is roughly on par with where London is. New York's much colder in winter than London is, and that's because London has the Gulf Stream, and warm water comes up across the Atlantic and goes up past the west coast of the UK, bringing warm water from the equator past the west coast of our country, delivering huge amounts of energy, which artificially escalates the temperature of London because the warm water warms the air, and that blows across the country. And so London is at one temperature, New York and Moscow much, much colder. But in summer, they have plenty of sunshine and weather systems that mean that they get a nice basking in the sunshine, so that the weather in the summer is much warmer. In California, much, much further south, and they tend to get a very stable climate most of the time with nice warm days, plenty of sun, not so much rain.
A question in just now. I think it's kind of a common problem with guys. Premature ejaculation or not lasting more than 1 minute. Is there something that can be done?
Well, premature ejaculation is something that we've decided is a problem because people find that it leaves their partner feeling unsatisfied and can lead to them feeling unworthy. But from an evolutionary point of view, what does nature want to do? Nature wants to make sure that you have as many babies as possible within the least possible time. And every individual wants to make sure their genes are fathering the next generation. Well, if it takes forever to make sure your genes end up in the other person or animal, then you're less successful than someone who actually is very fast. So evolution is trying to drive us towards getting the other person, individual animal, pregnant as fast as possible, not taking very, very long. So basically, to try and slow things down, you're fighting against what nature would like to happen, which is to get that interaction, which is risky, over and done with as fast as possible. And so people shouldn't beat themselves up about this. They should think, well, what nature wants to do is to make sure that I pass on my genes as fast as possible. And so bearing that in mind can sometimes help people to feel a bit more confident and comfortable. And then when they relax a bit, things do tend to take a bit longer anyway.
Yeah, I don't think he was referring to procreation at all with that particular question. But let's go to one of last week's questions. Hi, Clarence, Dr. Smith. When I move my neck, I sometimes hear liquid moving in the back of my neck. It happens since I'm a child. Is this normal? It doesn't cause discomfort, but I get headaches when I laugh. Giandre with that question.
Hi, Giandre. Well, there's a number of things to think about here. The spinal column or vertebral column is a sequence of bones. You have a number of them in your cervical spine, which is the curvy bit above your shoulders, your thoracic spine, which curves down where your lungs are, and then your lumbar spine at the bottom. Those bones all stack up on top of each other and are articulated by joints between the vertebrae. And as you move and twist, then those joints allow the bones to twist and curve and slide over each other. And as we move our head backwards and forwards, you are twisting each of those bones relative to the one above and below it a little bit so that you produce the range of movement that you've got. Those joints are facet joints. They are synovial joints, so they have a liquid in them, and that liquid acts as a lubricant and a shock absorber. There's also cartilage in there. So it's not unusual to hear or feel squidgy, clicking or movement noises when we move our heads around. Particularly as we get a little bit older, you may notice this more. If something has changed and you have got something which is restricting or limiting movement, you are getting an association between movement and pain, or you start to notice that you get pins and needles or something in your fingers if you move your head and this sort of thing starts to happen. You need to get that investigated. But if this is something that's always happened, it's almost certainly normal for you, and as long as it's not producing any other symptoms, then I'd say enjoy the fact that you can hear your physiology and anatomy at work.
Then we have the following question in. Dr. Chris, when looking at the night sky, why does it appear that the lights twinkle? Mary with that question.
Hi, Mary. The reason stars twinkle is twofold. In one respect, stars do not produce light at a constant rate. So some stars are continuously blowing up and shrinking a bit and producing pulses of light, which is brighter and dimmer, brighter and dimmer. But the most significant reason that stars twinkle is because of the effect of Earth's atmosphere. As the light from that distant star comes through the atmosphere, it passes through patches of our atmosphere which are more dense, thicker air, probably because it's colder, and patches of the atmosphere which are thinner, more rarefied, probably because it's hotter. And when light passes from a more dense medium into a less dense medium, it is caused to change speed, and this also causes it to curve or bend on its path a bit. And this is why on a hot day, when you see the road ahead, you sometimes see what appears to be water or the sky on the road, a mirage. And this is because you are bending the light that's coming from the sky and making it look to your eye like it's coming from the road, because the air above the road is very, very hot, and that hot air is less dense, which is changing the speed of the light going through it and bending it. Same phenomenon. So when you've got distant starlight, it comes to the Earth's atmosphere, the light goes through patches of hot and cold and hot and cold, in other words, dense and less dense air. This has the effect of continuously changing the speed of the light that's coming through, causing it to bend, and if it bends, it makes your eye think that the source of that light must be wobbling around. It's not the light to your eye that's wobbling, because your eye is programmed to believe that light always travels in straight lines, and so your eye says the source of that light must be moving, so it makes the star appear to wobble, which we call twinkling.
Thank you, Dr. Chris. Somebody, I think after our premature ejaculation question of earlier, asks the following question. In fact, it's from Solly. He writes, this premature question reminded me of a drunk debate I had with friends some time ago. Most animals have a mating season except humans. What would happen if humans had a mating season, say, every December? Absolute chaos, I think.
Quite possibly. Not all animals have a fixed mating period. Many do. Many are driven by seasons. There are some sheep. There's some species of sheep that can breed at any time of the year. Some birds breed at any time of the year. Pigeons, for example, reproduce all through the year. Other birds do have a mating season. And the reason many animals that are less good at controlling their environment have a mating season is they are in sync with when the land can provide the best environment to have a baby. And that means the temperatures are best, the predators are at a minimum, and the food is at a maximum. And so many animals have synchronized their mating period and therefore their reproductive period with what the world is doing to keep them alive and keep their babies alive to give them the best chance. Other animals that can either migrate or are less affected by those influences, and because we have warm houses we can often go into, we're not subject to that. As a result of that, we don't have this fixed mating period that some animals do.
And we're going to have to wrap it there. Big thank you again to the Naked Scientist. Dr. Chris Smith